Hello, how's everybody doing? My name is Kopil Bonov, and this is Big Data Application and Analytics Lab Assignment 3. And so this lab due on July 16 of 2018. And so first part of our assignment, our lab is Hadoop MapReduce algorithm. Implement MapReduce algorithm to find Facebook common friends problem and run a Map MapReduce job and Apache Spark. Use following database to run for your program and include the following algorithm. So this input. So let's go to our thing. So this is the input they gave us. So it's just just go down the list like 0 to like this is the input we got from there. And the second one, this was the input and this we had to work with, but we thought that was not good way to show how our our map reducer works. So this is our mapper here. So it gives keys and strings and users like that, and we have reducers right here. And then we created two of the files we can implement here. So first one is the use the input they give us. So this is the user they give us, and the second one is the one we created. So this is like A B C, like that. You can see that. So let's run this program. So now we're running this program. So here you should create one page called mapper and reducer for the first input, and second one has create Facebook mapper and reducer. This is the final results comes from reducer. Okay, so let's wait. You can see here it's working. It's doing its own job. Takes time. So this is it. So this is the one for this mapper and reducer. So let's see the results for it. So this is the results because it cannot handle it exists this much. So you see the results for from the mapper, and then this is our final results from the reducer. So you see it's getting the friends like that. So this is when we work with the inputs. I don't we didn't see like there was not a good example of we don't like this input because it didn't show how good our map reducer was. So this is our input from our mapper, from our input. So you see how organized it is and shows what's going on. And then we can see from here, this is the last part. You see the result, reduced it, and find the common friends and everything like that. So I think that our input was much better to the way to show how the the map reducer works. So from here we answered implement algorithm, Facebook common friends, and run the map patch. We run it. We run the input they gave us, right? Include the algorithm, result, and screenshots. So we already did this. So we see how friends and like this, and this common friends, friends person. So this was explain how we did, how we should do it. So we did both of these things. So we are done with this. Now we have to go to second part. This was Spark Data Frame. So we had to Spark Data Frame, and we had to choose one of the three data sets. We choose FIFA World Cup because it's a World Cup, so we choose this one. And so from there, let's go to our making sure this is running. Okay, now we're done with part one. Let's get out of here. So this is our part two. Ooh, there's a lot of codes. So first thing first, we had to do create the Spark database frame using one of the datasets, trying to use all different type of structure types. So you can see here we did um so we I had to use this so like my battery works. So you see here we are loading data and we just put the initials of fauna into strings, and the shares strings, and headers is true. So if I do div f show here, we can see that run this. Oh shit. Fuck. Oh, sorry. It's some reason running this thing. It was accident. So let's run actually the part two. Some reason when I clicked it, it gone to my first part, and it's because it's already the files are created here. It cannot create the file two times. Files. You see from data show, we can see all the data entered from the called World Cup matches. You see all the teams, all the things. First parts are null. Yeah. So you see all of them, all our data. It's just 20 rows. First 20 rows of it there. So let me turn off this part. Okay. Then because you see like we have null things and like that, we don't want to deal with those things, so we turn off it. So you see here, so matches filtered, so only years. If it's not, then it's not gonna accept it. and and then here we create the SQL, um, uh, for using SQL. So we create a template table called World Cup matches, and then this is accessing this table. Okay. Okay. So we're done with this. So second part we had to okay, B and C are kind of together. So first we had to create the innovative question, 10 innovative question datasets, pattern recognition, topic, discuss more important term, use innovative thinking out of the box. Okay, and then perform any 5 queries in Spark data frames, compare the results. So with uh, this is all together gonna be 20 requests. You can see we have 20 requests. So so the thing we did was first we did the first 5 the individual questions. So this is our first one. God damn it. So this is our first one. So this is asking for which year highlights the score the game for an average. So we can run that. See, it's running everything like that, but it's gonna show for all of those things. So we can turn off this and go to next one. So this is gonna be average attendance. You see this average attendance, and this is gonna be the most common reference for each year. And then you see this the and so this is the fourth one. You see the most common reference for each year. This is the most common referees. This is the most common referee 2014. He was the most common one to use. And then this one lists all the referees. You see, it's running perfectly. Alright, now we go to the second part. Okay, we are done with the first five of the interview questions, so now we're gonna deal with so now we're gonna combine the B and C together. So we're gonna last five of our interview questions gonna be reproducing SQL and Spark RDD and Spark data frame. So you're gonna expect three results from the, this place. So when we run first part, so this is the SQL and this is the database frame, and let's open this. So this is three of them, running all of them. So you can see from result, this is the first one is SQL run. So Diego Paris 9. You can see here, this is one with the our SDFs. You see it's a result is mostly similar. And then we can see from here, this is the one we did RDD. So you see RDD, so France, for France, 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 oh, France, oh, France is not in this list right now because this list is short. Okay, or maybe I'm typing wrong. This happens all the time. Oh, that's why. It's not France, it's Paris. Okay, you see Paris 9. Okay, so you see everything is like that. So this is the first part. So that's counting countries. So and then second part we had to do who was in a group 1 each year. So we had to figure out who was in a group 1 each year. So up and down, close this, open this up, and then RTD, create this, run. Okay. Okay. So from result you can see all the names. You see 1930 France, 1930 Argentina. This is the result from SQL, and then you can see um, from this is from the RDF. This is the results. You see Mexico. It's just they have similar results, and we can go here. You see here part one. For some reason you can see all of you see France, it's Italy, Mexico, Chile, all those places. So you see it matches perfectly. Okay, so we're done with that part. Now we're gonna go to total attendance per year. So this is calculus each year how many people actually attended each year. So that just open that, then we go open. Okay, so from here you can see 1990 attended so much people, 1990 attended so much. This from SQL and this from the RDF, and This is our result from. Oh, nope, not this one. Sorry. Nope, not this one. Oh, I'm blind. It's right here. Sorry. So you see, so find 1990, you see the number, and it matches perfectly with this number. So our code's working perfectly. Okay, we're done with that. Then we're gonna do which games had all goals in second half. So, second half people goals. So let me run this now. So, sorry, I cannot do collect and show it here because I have Windows and Windows cannot handle it. So you can just do collect if you think can handle it, then you can just do collect here. Okay, so here this is our result from RDD. You see that? So 1990, they have 0, so halftime 1, you say 1. 1992, they have 4. And this are SQL. Yeah, see goals, so just count all of them like that. So code is perfectly working. So let me turn off this. Okay, we're done with that. Okay, this is the uh, this is the problem we had with the thing. One of the things we had to do was compare the results. In most cases, we can see that RDF is working perfectly, and you can see from examples between and SQL and RDF, if it's we asking for a simple request from the database, like usually SQL and RDF is there have similar codes and similar thing they ask you for. So it's easy to do. More complex in case the SQL and RDF. SQL is simpler, but RDF gets more complex when asking more complex answers. And then the one of the things we had to do was percent of games by team. This was the really we choose this part because this is one of the super complex um, requests we can ask from database. So this request is actually works on my partner's computers, like, but when I run it on mine, is not gonna run because the reason is because my computer processor cannot handle this request because it's too complex for it, so my processors cannot actually um can handle. You see here, it's saying it's bunch of faults and like that, but it's because my thing cannot handle it because it's too many uh, things going on in there, so it's my processor cannot handle all these things. And RDF is similar to SQL, so this is ask for like a lot of processing power that I don't have on my computer. But if we can show with my partner's computer, and this program's perfectly runs on his. So RDF can handle like this complex. This is the one of the best thing about RDD because it can handle really complex requests uh, from requesting like it doesn't request a lot of processing power to do its own requests. So when I work on it, this actually works if I only use RDD because it doesn't use much processing powers to do extreme complex requests from database. So see. You see, it works here. You can see here our results, and this is our results. You see that? So from we can when we comparing all these things, like part C of our assignments was uh, compare the results. So when we compare the results, most times the SQL and SQL data frames usually are similar, but more complex as the request is, the Spark data frame gonna get more complex to do or bigger to get the request. And if it gets really extreme difficult, um, SQL and Spark data frame uses a lot of processing power. If your computer doesn't have that processing power, then it's not gonna work. Uh, in other case, RDD um, can do a lot more complex requests uh, and asking, but it doesn't use a lot of processing powers because it goes individually. So when you do it, it can actually get results from database. So that's what we learned from the Spark database frames. Okay, this is all our assignments. Thank you very much for the video.